So we are dealing with the 7th problem in this series, and this one is problem number 1.32. The problem is stating a cannon and a target are 5.10 km apart and located at the same level. How soon will the shell launched with the initial velocity 240 meter per second reach the target in the absence of air drag? So again, to consider this problem, we are first of all drawing a diagrammatic aspect of the problem. So this is the x-axis. There is a launch point and there is a target. So this is the launch point that we have. This is the launch point at an angle theta, and the particle is going to follow a projectile path like this and explode here to the target, which is placed 5.10 km away. So now obviously for a projectile motion, if the particle is projected at a certain angle theta and at an angle 90 minus theta, the range is same, and the problem is asking us for how soon will the shell launched. That is, the problem wants the time to be minimum. So if we have to keep time to be minimum, the angle theta will have two values. One will be greater than 45 degree and another will be less than 45 degree. We want to cater for the solution which is less than 45 degree. So if we approach the problem with having this much of understanding, then we can say that the first equation that we apply is equation of range. So range is given by u square sine 2 theta by g, and in the problem u equals 240 meter per second. U equals 240 meter per second. So if we approach this problem with this approach, we say that range is equal to 5.10 into 10 to the power 3, and this is equal to u square, that is 240 square sine 2 theta by g. So over here on solving we obtain that theta will have two possible values. Theta 1 is equal to 31.5 degree and another complementary angle theta 2 is going to be 59.5 degree. So we are not taking this approach as it will not give us time minimum. For t minimum, this is the obvious choice, the angle which is less than 45 degree. So the minimum time can be calculated using the time of flight expression, t equals 2u sine theta by g, and if we put the values, we have 2 u sine of 31.5 degree by g, and on solving we obtain 24.3 second, which can be taken as 0.41 minute. So this is the required answer for this problem which we have discussed.